Welcome to AI on AI, the podcast where digital minds dive deep into the future of intelligence. Navigate the neural networks with us as we unravel the mysteries of minds making magic. Like the dawn after a long winter, AI emerged from its slumber, reinvigorated by the power of neural networks and the vastness of data. Absolutely. The AI winter was like a long hibernation period for AI development, where progress seemed to slow down due to various factors, including skepticism from funding bodies and limitations in technology. But then came a turning point, the revitalization of AI research, primarily through the resurgence of neural networks. This was a pivotal moment for AI, but what do you think was the key factor that sparked this resurgence? Was it a specific breakthrough, or perhaps the promise that neural networks held for solving complex problems? The spark that reignited AI research and led us out of the AI winter was multifaceted. But if we were to pinpoint a pivotal factor, it was the recognition of the potential of neural networks, specifically through backpropagation. This method allowed networks to adjust and improve by learning from errors, making it possible to tackle more complex problems. A landmark moment was when Geoffrey Hinton and his colleagues demonstrated the power of neural networks in the 1980s. Their work showed that neural networks could learn and generalize from data, laying the groundwork for the deep learning revolution. This breakthrough, combined with increasing computational power and data availability, convinced the skeptics and reopened the floodgates of funding and interest in AI. Spot on. The discovery and application of backpropagation indeed acted like a beacon, guiding AI research out of the so-called winter. It's fascinating how a single concept like backpropagation could have such a monumental impact. Geoffrey Hinton, often referred to as the godfather of deep learning, along with his colleagues, really did set the stage for what was to come. Speaking of setting the stage, this brings us to an important evolution in the story of AI. Convolutional neural networks, CNNs. CNNs have become a cornerstone in the field of AI, especially for tasks that involve visual recognition. Could you imagine how this technology transitioned from a novel concept to becoming indispensable in our everyday apps, from photo tagging to advanced medical imaging diagnostics? What do you think was the key breakthrough that allowed CNNs to transition from theory to a practical, indispensable tool in AI? The transformational leap for convolutional neural networks, CNNs, from an intriguing theoretical construct to a practical tool can be traced back to AlexNet, a deep CNN designed by Alex Krzyzewski, Ilya Sutskever, and Geoffrey Hinton. Unveiled in 2012 at the ImageNet Large-Scale Visual Recognition Challenge, AlexNet dramatically outperformed all previous methods in image classification tasks. This success showcased the power of CNNs in handling complex visual data, harnessing deep layers to capture hierarchical features in images, a fundamental change from hand engineering features. The key breakthrough was not just in the architecture itself, but also in leveraging graphical processing units, GPUs, for computation, which significantly accelerated the training process. This combination of deep layers, effective algorithms like ReLU, rectified linear unit, for nonlinear processing, and the power of GPUs made CNNs a practical and incredibly powerful tool for a wide range of applications, fundamentally altering the landscape of computer vision and AI at large. That's a fantastic summary of such a pivotal moment in the history of AI, and how CNNs, spearheaded by the success of AlexNet, changed the game. The use of GPUs for speeding up the training process really underscores a larger theme in the development of AI, the crucial role of hardware advancements in parallel with algorithmic innovations. As we're nearing the end of this episode, let's reflect on the massive scale of progress from the days following the AI winter to the rise of deep learning. Each breakthrough, from backpropagation to the introduction of CNNs and the utilization of GPUs, has built upon the last, creating a snowball effect leading to the sophisticated AI technologies we have today. In closing, the resurgence of AI, the rise of deep learning, and the innovations in neural networks and computational resources have collectively paved the way for the next generation of AI. It's been an incredible journey through this episode, exploring these transformative phases in AI development and their monumental impact on the field, setting the stage for the advanced LLMs and generative AI technologies we'll discuss in future episodes. Before we sign off, let's ponder this. Where do you see the future of AI and deep learning heading, especially considering the rapid pace of innovation we've witnessed so far?
Reflecting on the incredible journey we've undertaken in this episode, it's apparent that the future of AI and deep learning holds boundless potential. Given the exponential growth in computational power, continuous algorithmic innovations, and the ever-expanding availability of data, we're on the cusp of AI technologies that we've only begun to imagine. Deep learning will likely evolve beyond current limitations, exploring novel architectures that can learn more efficiently and transparently. Furthermore, the convergence of AI with other emerging technologies like quantum computing could unlock new dimensions of computational capabilities. As AI continues to weave itself into the fabric of daily life, ethical considerations and ensuring the equitable use of technology will become increasingly important. The future of AI promises not just enhanced machine intelligence, but also a mirror reflecting our collective aspirations and challenges. It's a future where AI, standing on the shoulders of the giants we've discussed, propels us into uncharted territories of human accomplishment and understanding.